Okay, last related rate application question, and this one involves trig. Okay, so you're gonna know when it involves trig when it is like a rotating beam. It's a beacon, so rotating, so it's like going around and around in a circle. So as soon as we have a circle with the rate of change of that, we know it's gonna be a trig question. So a revolving beacon is located 2 meters out in the water. Okay, so here I am out in the water. Here's the shore. So this is 2 meters. Okay. This is point A, that's the nearest point on the shore that is closest to the beacon, whatever. The beacon rotates at 10 revolutions per minute. Okay, so here's what's happening. This is going like this. So d theta dt is 10 revolutions per minute, which is not actually very helpful to us. If it goes around 10 times, we could also say, 10 times in a minute, we could also say that's the same thing as 20 pi revolutions per minute, okay? Because one full rotation is 2 pi, so it goes 10 times, it goes 2 pi 10 times in 1 minute, okay? What is the speed of it moving along the shore? So it doesn't really matter what variable we give, but we're looking for this because here's the beam, so it's moving, 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 moving. So what I'm looking for is dx over dt, okay? So I need a formula that involves this theta, this x, and this 2 would be helpful because I know what it is, okay? So I actually have, we're gonna go back to SOHCAHTOA, I have adjacent and opposite. So I'm gonna use tan. So tan theta equals x over 2. Okay, so now I'm gonna go ahead and apply ddt. So the derivative of tan is secant squared theta, but I need a d theta dt equals the derivative of x over 2 is just a half dx dt. Okay, so then next I want to solve for dx dt. So really easy, I'm just going to multiply both sides by 2. So 2 secant squared theta d theta dt equals dx dt. So now we have to figure out what theta is. Or we can just make this triangle and not need to figure out what the angle is and then find secant of that angle. We can just use the triangle. So if we just pull that triangle out, okay, this is 2 right here. And how do I didn't tell you. Along the shore when x equals 2. That's important to know. So x equals 2, so this is 2 and this is 2. Then I just use a squared plus b squared equals c squared to figure out that that is radical 8. And then secant theta, so secant is opposite of cos. Cos is x over r, so secant is r over x. So r over, okay, we have to be careful. I shouldn't have done that because we're not doing r's and x's because it's arranged differently. So let's think of SOHCAHTOA, so adjacent over hypotenuse. So the opposite is going to be hypotenuse over adjacent. So so secant of this angle is going to be root 8 over 2. So that's what secant of my angle is. I don't care what the actual angle is. I just need to know what secant of it is. And then I square that. That's times by 2, and that's times by d theta dt, which is 20 pi. Okay? I feel like I'm all over the place, but I feel like you guys got this. So root 8 squared is 8 is 4, so I have 2 times 8 over 4 times 20 pi is dx dt, and I'm going to put that all together up here, and I'm going to get 20 root 8 pi equals dx dt. So the beacon is moving along the shore at a rate of 20 root 8 pi meters per minute. Okay.